Is to go over the Unit 4 Solving Polynomials test review. So for number 1, so it tells us to factor f of x. So first thing, remember when you're factoring, you want to check to see, do your terms have anything in common that you can factor out? So can you factor out a GCF? And then from there, you can see what you got left to see if you can factor some more by one of the other methods. So for this one, you would look at your coefficients. So we've got 4 and 36. So the biggest number that divides both of those would be 4. And then we've got x to the 4th and x squared. Remember, for your variables, you take the smallest exponent. So smallest exponent is x squared, so we can factor out 4x squared. And then what's left in parentheses. So remember, we are factoring this out, so technically we are dividing our terms by this GCF, and that's what's left inside. So that's one way to think about it. Or you could think about 4x squared times what would give you 4x to the 4th, and then same thing, 4x squared times what would give you negative 36x squared. So 4x squared times x squared would give us 4x to the 4th minus 9, because 9 times 4 is 36. So we factored out the GCF. Now we can see what's left in parentheses. So what's left in parentheses is a difference of squares. So we can factor this some more. So remember, we square root. And then because this is a difference, our signs are going to be different. So 4x squared is our GCF. And then this is going to factor x plus 3, x minus 3. So now our problem is fully factored. So if it's not multiple choice, then obviously you're going to have to know how to factor, or just pray that the guessing gods are with you. If it is multiple choice, though, you can type in your original and then type in your answer choices to see which one gives you the same graph. All right, same type of thing on number 2. So again, we are factoring. Check to see, is there a GCF? There is. So we've got 3 and 24. So biggest number that divides both of those would be 3. We've got x to the 4th and x. So smallest exponent would be x. And then let's see what's left in parentheses. So 3x times what is 3x to the 4th? That would be x to the 3rd. And then 24x. So I need to multiply 3x by 8 to get that. So we factored out the GCF. Now we check to see what's left. So we've got x cubed plus 8. So this is a sum of cubes. So remember, for a sum of cubes, we cube root, and then we're going to fill in our factors. So GCF is 3x, and then for a sum or a difference of cubes, you got a binomial factor and then a trinomial factor. So remember, cube root, so that's the first part. So cube root of x to the 3rd is x. Cube root of 8 is 2. And then we square, so x squared. Multiply, so 2x. And then square, so 2 squared is 4. All right, and then we place our signs according to SOAP. So same, so it was a sum of cubes, so that's going to be a plus. Opposite, so it was a plus, so this one's going to be a minus. And then the last one is always positive. So these would be my factors. So this was a sum of cubes. So this right here, final answer. And again, if it was multiple choice, you could type in your original, type in your answer choices, and get the one that matches the graph exactly. So you should only see one color, one graph. That's how you know that they are the same, can't talk. So that's how you would know that that's your answer. All right, number 3. So we've got the area of a rectangular garden is represented by 9x squared minus 25. Which binomial factor could represent the length of the garden? So this is asking us to factor. So we've got 9x squared minus 25. That is a difference of squares. So that's going to factor just like number 1 did. So we're going to square root. So 3x plus 5, 3x minus 5. So which one of those is a factor? So maybe it's just me, but I'm seeing 3x minus 5, and I'm also seeing 3x plus 5. So I'm seeing both. So I'm not sure if this is a typo or like a select all that applies, but uh, both of these factors could represent the length of the garden or the width because they don't give us any other specifics. But I guess I'm going to go with 3x plus 5, but technically it could also be a. All right. Number 4, find the roots of the equation. So terminology, so you need to know what roots mean. So roots are your x-intercepts. Your x-intercepts are where the graph crosses or touches the x-axis. So you're going to graph this and see where does it cross or touch the x-axis. And our degree is 2, so we should see 2 solutions. So hopefully the solutions are real, because if they're not, then we're going to have to solve this by the quadratic formula. So 6x squared minus 17x plus 12. All right. All right, so here we are. So these are our solutions. Remember, if you get decimals and they are repeating decimals or terminating decimals, change them to a fraction. So like this is 1.3 repeating. So remember 1.3 and then spam the 3 until the fraction disappears and then reappears. All right, so that is 4/3. So one of our roots is 4/3. And then 1.5 is a terminating decimal. So I can just type in 1.5 and that gives me 3/2. So my other solution or my other root would be 3/2. So that right there, final answer. All right, question, or well, y'all can't ask questions because, yeah. All right, number 5. Find the quotient when that is divided by x minus 2. So our divisor is linear, so we can do synthetic division. Remember, whatever we are dividing by, we are going to switch the sign. So it's x minus 2, so we're going to use positive 2 for synthetic division. All right, and then we check our dividend to see, are we missing any terms? So you look at your exponents, are they going down in order? So 4, 3, 2, 1, nothing. So exponents go down in order. We didn't skip over any numbers, so we're not missing any terms, so you don't have to worry about placeholders. So we write down our coefficients. So that's 1, 1, negative 11, negative 5, and then 30. All right, so remember, whatever that first number is, it always drops down. All right, then we multiply. So 1 times 2 is 2. Then we add. So 1 plus 2 is 3. 3 times 2 is 6. Negative 11 plus 6 is negative 5. Negative 5 times 2 is negative 10. Negative 5 minus 10 is negative 15. Negative 15 times 2 is negative 30. 30 minus 30 is 0. So this one divides evenly because we do not have a remainder. So that's also going to mean that x minus 2 is a factor of this polynomial. So then remember the way you write your answer. So because we are dividing by x, that is going to knock your exponent down by 1. So we started with x to the 4th, so our quotient is going to start with x to the 3rd. And then these numbers are your coefficients. So that's going to be x to the 3rd plus 3x squared minus 5x minus 15. So that right there would be your final answer. And I'm going to add this in even though it's not asking, but I'm going to write it in a different color so it stands out. Let's see. Yep, we'll use purple because why not? All right, so x minus 2 is a factor because the remainder is 0. So remember, remainder factor theorem. So if you go through and divide, if your remainder is 0, that means whatever you divided by is a factor. If you get something other than 0, that means whatever you divided by is not a factor. So because that was 0, because this divided evenly, x minus 2 is a factor of this polynomial. Okay. All right, sorry for the brief little intermission. Okay, so that's number 5. So if your divisor is linear, you can do synthetic division to divide. Remember, last number is your remainder. So if you were to have a remainder, remember it's always plus, and then whatever your remainder is over your divisor. All right, number 6. So on number 6, you would actually do polynomial long division on this one because your divisor is quadratic. I did not talk about this. And on the test, this problem is multiple choice, so I did show y'all how to match the graph. But for this problem, I am going to work it out the way it's supposed to be worked out. So you take your dividend, and basically you set up the problem like you would if you were doing regular long division with numbers. So I set up my little house. So my dividend goes under the house. So x squared plus 6x plus 8. Oop, I made my house a little too long, but it's all good. Your divisor goes out front. So x squared minus 2x minus 8. All right, so then it's set up. So now when you do when you do long division, you take your first term and divide it by your first term in your divisor. So x squared divided by x squared, so that would be 1. So then I'm going to take 1 and I'm going to multiply it through my divisor. So my divisor is 3 terms, so I'm going to end up with 3 terms under here. So 1 times x squared is x squared. 1 times negative 2x is negative 2x. 1 times negative 8 is negative 8. And then we draw our line, change our signs. So that's positive, so now that's going to become negative. That's negative, so now that's going to become positive. That's negative, so now this is also going to become positive. All right, so now we just combine. So x squared minus x squared, so first term should always cancel. All right, so then here I've got 6x plus 2x, so that is 8x. And then I've got 8 plus 8, so that's 16. All right, so this right here would be my remainder because I'm left with 8x. My divisor is x squared. I can't divide x by x squared and get a whole number. So we're ready to write our answer. So final answer would be 1 plus, and then remember it's your remainder. So 8x plus 16 over your divisor, which was x squared minus 2x minus 8. All right. And if you're actually watching the video, I need for you to put a star next to number 6. So on your paper next to number 6, I need you to put a star. All right. Number 7. So what value for k will make this equation true? So there's a couple of different ways that you could do this problem. I'm going to do this problem using sliders. So we are going to type that in. So type that in, add a slider for k. You're going to type that in. And then you're going to slide the slider for k until the two graphs match. All right, so that's what I'm about to do. So let me pull up. Excuse me. All right, so 5x to the third plus kx squared minus 24x plus 45. And then our divisor is x plus 3. Add my slider. All right, and then underneath that, I'm typing in this. So 5x squared minus 10x plus 6 plus 27 over x plus 3. All right, so let me hit home. There we go. Okay, so I've got two graphs. I got a blue graph and a black graph. So I'm going to slide my slider until the graphs match. So I'm trying to match the black graph to the blue graph. So if I go to the left, so if I make k negative, that's going in the wrong direction. So let's make it positive. All right, so I've got k equals 5. So let me click the blue graph off. Yep. So directly underneath my blue graph is my black graph, so they are exactly the same. So k is going to equal 5. And then you can also zoom in to see if you see two colors like super close together. We do not, so again, that's definitely our answer. So k equals 5. Oop, y'all can't see. All right, so that is how you would do that one. That's one way to do it. You could also do synthetic division and work backwards to figure out what k is, because you know that your remainder is supposed to be 27. So yeah, so that's another way that you could do it. But I'm not going to demonstrate that in the video. All right, number 8. When that is divided by x squared plus 1, the quotient is, so again, our divisor is a quadratic, so we would have to do long division. I'm not sure if this divides evenly or not. Honestly, we could check that. Let's check to see if it divides evenly first. All right, so I'm going to type in 3x to the third plus 2x squared minus 5x plus 4 over x squared plus 1. Okay, so it does not divide evenly. So it was worth a shot. So I am going to do long division like I did on number 6. Okay, so dividend is going to go under the house. Divisor is going to go on the outside. So x squared plus 1, 3x cubed plus 2x squared minus 5x plus 4. All right, so 3x to the third divided by x squared, so that's going to be 3x. 3x times x squared is 3x to the third. 3x times 1 is 3x. Alright, draw my line. Change my sign, so both of those were positive, so both of these are going to be negative. That's going to cancel. We didn't have a term to put with that, so that 2x squared is just going to drop. And then negative 5x minus 3x, so that is negative 8x. And then I'm going to drop down my next term, which is a 4. And I'm going to start the process over. So 2x squared divided by x squared, so that's going to be 2, because the x squareds are going to cancel. And honestly, from there, we don't have to do any more because it asks for the quotient, not the remainder. So that's going to be 3x plus 2. But I will go ahead and finish this out. So then I would do 2 times x squared, which is 2x squared. 2 times 1, which is 2. Draw my line, change my signs. 2x squared is going to cancel. Nothing to put with that, so that's just going to drop. And then 4 minus 2 is 2. So that right there would be your remainder. So then that would be plus negative 8x plus 2 over x squared plus 1. But all they wanted was the quotient. So the quotient is the part before the remainder. So 3x plus 2. All right, so that's your final answer for number 8. All right, number 9. So the function f of x has a factor x minus 2, and ax squared plus bx plus c. What is the value of a plus b plus c? So they're telling us this is a factor, which means we can divide this by that, and we're going to get this polynomial. And then this is asking us to add our coefficients together of this polynomial. So our divisor is linear, so we can do synthetic division. So it's x minus 2, so we're going to switch the sign, so positive 2. Check to see if you're missing anything. So 3, 2, 1, nothing. All right, so not missing any terms, so we can go ahead and write our coefficients. Don't have to worry about placeholders. Drop the 2. 2 times 2 is 4. 1 plus 4 is 5. 5 times 2 is 10. Negative 8 plus 10 is 2. 2 times 2 is 4. 0. All right, so this would be my A, this would be my B, this would be my C. So I'm adding them together. So 2 plus 5 plus 2. So 2 plus 5 is 7. 7 plus 2 is 9. So 9 would be your final answer. All right. So again, if you are watching this, which you should be watching this and not just copying it down, I need you to put a square around the number 9 for the problem number.
Mason Jones, if you are in the building, please report to the main office. Again, Mason Jones, if you are in
All right,
the
number
building,
10.
please report to the front office.
Find all the factors of f of x. So remember, in order to write your factors, you need your x-intercepts. So we are going to graph this and see what our x-intercepts are. All right, so I'm going to graph this right quick. So I'm going to pull up Desmos. All right, so x to the third plus x squared minus 16x minus 16. All right, so I've got 3 x-intercepts. So remember, whatever your x-intercepts are, you switch the signs to write them as factors. So I've got negative 1, so that would be x plus 1. I've got negative 4, so that would be x plus 4. And then I've got positive 4, so that would be x minus 4. So remember, whatever your x-intercepts are, you switch the signs. So our x-intercepts were 4, negative 4, and negative 1. So we switch those signs to write as factors. switch signs to write as factors. All right. You also could have done factor by grouping for this if you were taught that. So remember, you group the first two terms together, factor out the GCF. Same thing for the back, and then go from there. So then from there, you would factor out your GCF to get your factors. Okay. So for number 11, which of the following is a factor of x to the third minus 5x squared plus 3x minus 15? So we've got two linear possibilities. So we can start by graphing this just to see if we can see what our x-intercepts are, because that would give us a clue as to whether this or this would be our answer. And if it is, great, we found our answer. If it's not, then that also helps us narrow it down. So then we would have to do long division with one of these to see if it divides evenly. And then obviously the one that we pick, if it does, that's our answer. If it doesn't, then obviously our answer would be the other one. So I'm going to graph this first. So going along the lines of this, I'm going to get my x-intercepts so that I can switch the signs to see if one of those is one of the factors. So let me type that in. All right, so x to the third minus 5x squared plus 3x minus 15. All right, so we get positive 5, so that means x minus 5 would be a factor. So this says x plus 5, so that's a no. And then the only one that we see is that, so this one's also a no. So we're going to have to do division to see which one divides evenly. All right, so just like I did on the first page. So I'm just going to go with A and divide and see if it divides evenly. So x squared plus 5. Put my dividend, so x to the third minus 5x squared plus 3x minus 15. All right, so when I do this, I'm doing x to the third divided by x to the second. Which would just be x. So there's an issue with number 11. Anyway, so that would be x. Wait, there's not an issue because I'm seeing does it divide evenly. Oh, so no. So positive 5 was an x-intercept. So when I'm going through this, I should be left with x minus 5 up here since I'm dividing this out. Okay, sorry, brain fart. All right, so x to the third divided by x squared is x. All right, so then I'm going to multiply that back through. So x times x to the second is x to the third. X times 5 is 5x. All right, draw my line, change my signs. So both of those are positive, so both of these are negative. That cancels. This drops down. So negative 5x squared. 3x minus 5x is negative 2x. And then drop down my negative 15. All right, so then I start the process over. So negative 5x squared divided by x squared, so that's going to be negative 5. Multiply the negative 5 back through. So negative 5 times x squared is negative 5x squared. Negative 5 times 5 is negative 25. Draw my line. Change my signs. So both of those are negative, so both of these are going to be positive. That cancels. Negative 2x, and then negative 15 plus 25 would be 10. All right, so that leaves us with a remainder. So that's going to mean that C is our answer because we want it to be a factor, which means we want it to divide evenly. This did not divide evenly because negative 2x plus 10 is the remainder. So answer would be C for number 11. All right, 12, what is the remainder when p of x is divided by x minus 1? So you could do synthetic division on this one, although I do not recommend it because it is just asking about the remainder. You need to do the remainder theorem. All right, so remainder theorem. So remainder theorem says whatever you were dividing by, you were going to switch the sign. So it's x minus 1. So I'm going to plug in a positive 1. So I need to figure out what p of 1 equals. So we're going to type this into Desmos exactly the way it looks. And then we're going to type in p of 1 to get our answer. All right, so let me pull up Desmos. You also could evaluate in the calculator if that is your chosen method for evaluating. So x to the third minus 2x squared plus 13x plus 8. And then we are evaluating p of 1. All right, so we get 20. So 20 would be your answer for this one. All right, again, if you are watching this, I want you to circle 20 instead of putting a box on it. I put a box on it in the video, but I need for you to circle it. So circle, not a box. All right, 13. Which option accurately describes whether x minus 2 is a factor of f of x equals x to the third minus 1? So if x minus 2 is a factor, when we graph this, that means that the graph should cross or touch the x-axis at positive 2. So let's see if it does that. So x to the third minus 1 should cross or touch the x-axis at 2 if x minus 2 is a factor or not. So let's graph it and see. So x to the third minus 1. So it crosses at positive 1, not positive 2. So that means that it's not a factor. So let's look at our answer choices. Both A and B say it is a factor. We know it's not a factor because the graph did not touch the x-axis at 2. It touched at 1. So not a factor, not a factor. So this is saying f of 2 equals 0. That would mean that it is a factor. This is saying that f of 2 equals 0, or no, equals 7. That would mean that it is not a factor. So we're going to go with that one. Also, basically, we also could have done remainder theorem. So we want to find what f of 2 is. So that would be 2 to the third minus 1, which is 8 minus 1, which is 7. So that's where the 7 is coming from. So f of 2 equals 7, which means it is not a factor. So remember, in order to be a factor, remainder needs to be 0. If you get anything other than 0, not a factor. So 13 is C. 14, given f of x and the remainder of f of x when it's divided by x minus 2 is 14. What is the value of k? So this is another slider question. So we're going to type f of x in and add a slider. All right, it says when f of x is divided by x minus 2, well, we're going to do f of x divided by x minus 2. No, we're not. We're just going to do f of x. So we're going to type in f of x and add this slider. It says when it's divided by x minus 2, the remainder is 14. So we're going to apply the remainder theorem. So x minus 2, so then we're going to plug in positive 2. So then we're going to type in f of 2, and we're going to slide the slider until it equals 14. All right, so that is the process, so that's what I'm about to do. So let me pull up Desmos. All right, so f of x equals x to the third plus kx minus 6, add my slider, and then I'm evaluating f of 2. So I'm going to slide the slider until this equals 14. Oops, too far. There we go. So f of 2 equals 14. That's what they said. So the k value would be 6. All right. Again, if you are watching the video instead of just copying it, I need you to write the word pink next to k equals 6. So write the word pink next to k equals 6. All right, 15. So including all real and imaginary solutions, how many solutions exist for the function? So remember, we figured that out by looking at the degree. So your degree is your biggest exponent. So in total, we should have 4 solutions. So then we're going to graph it to see how many real and how many imaginary we've got. All right, so 3x to the 4th minus 12x to the 3rd plus 2x minus 4. All right, so the graph crosses at 2 spots. So we've got 2 real solutions because we can click on them, we can see them. That means the other 2 solutions have to be imaginary because we cannot see them. So 4 solutions in total. We've got 2 real, so we can see them. And we've got 2 imaginary because we can't see them. So your number of real plus imaginary should add up to the total. So 2 plus 2 is 4. All right, so that would be your answer for number 15. So we've got 2 real solutions, 2 imaginary solutions for a total of 4 because our degree is 4. All right, 16. Which pair of values could not be the roots of a cubic polynomial? So remember, a cubic polynomial means the degree is 3. So we should have 3 solutions in total. So for this one, so we've got 3, -7, and 4i. So remember, if you've got I in your solution, they come in pairs, so it's got a conjugate. So 4i would be a root. -4i would also be a root. So this one actually has 1, 2, 3, 4 solutions. So that means the degree would be 4, not 3. So it's not A. This one, we've got -2, 2, 3 plus 5i. So again, I is involved, so the conjugate would also be a solution, so that would be 3 minus 5i. So again, we've got 1, 2, 3, 4 solutions in total, so it can't be that, because remember, we need 3. This one, negative 3i and 5i. So both of these have I, so both of these have conjugates. So that would be 3i, negative 5i. So again, 4 solutions, not 3. All right, this one we've got 1 and negative 7i. So I on this one, so this one has a conjugate, so that would be 7i. So that is 1, 2, 3 solutions for a degree of 3. So answer would be D. 17. What is the total number of real zeros? So your real zeros are the ones that you can see on the x-axis. So that means we need to graph it. So we're going to graph this and see how many real zeros that graph has. All right, so x to the 5th minus 2x squared plus 1. So how many real solutions does this have? So one solution there, another solution there, another solution there. So we've got 3 real solutions, which is going to make the other 2 imaginary for a total of 5 since the degree is 5. But this one isn't asking about the imaginary, it's just asking about the real. This graph crosses or touches the x-axis 3 times, so there are 3 real solutions. So 3 real zeros. All right, so that's 17. 18, a polynomial equation with real coefficients has roots of plus or minus 4i, 3 minus 2i, and 5. What is the minimum degree of the polynomial? Okay, so we've got plus or minus 4i. So we've got both for that pair, so we're good on that. So that's 2 solutions. Three minus 2i, so we're missing the conjugate on that. So another root would also be 3 plus 2i, so that's another 2 solutions. And then we've got this real solution 5, so that's 1 solution. So then altogether, 2 plus 2 plus 1 is 5. So the minimum degree of this polynomial would be 5. All right, so minimum degree would be 5. All right, so that is number 18. And we are almost done. All right, 19. So find all zeros if f of x equals this and x minus 2 is a factor. So we want to find all the zeros. So remember, you should always start by graphing. So we're going to graph this and see if we can see all of our solutions. Hopefully we can, but if not, then we're going to have to do synthetic division and solve by either the square root method or quadratic formula. Minus 3x squared minus 8x minus 3. All right, so let's see what we can, ooh, that's not what I wanted. Let's see what we can see. Okay, perfect. So degree is 3, so we can see all 3 solutions. And all 3 are rational. Perfect. Okay, so our solutions are negative 1. That's a decimal, so remember we need to change that to a fraction. So negative 1/2. And then our last one is 3. So those are our 3 solutions. So x equals negative 1, negative 1/2, and positive 3. All right. So that's our answer for 19. All right, for number 19, write purple next to where you wrote your answer. So write the word purple next to where you put your answer. All right, number 20. Find all zeros. So again, we're going to start by graphing. Let's see if we can see everything. Most likely we won't though, because we did for the first one. But let's see. All right, so we've got x to the third minus 2x squared plus 5x minus 10. So yeah, no, we only see one solution, and that's the one that they gave us. So remember, they told us x minus 2 is a factor, which means positive 2 would be a solution. So we're going to use positive 2 to do synthetic division, and then we're going to solve the quadratic that is left. So positive 2. Synthetic division, check to see if you're missing anything. So 3, 2, 1, nothing. All right, so we're not missing any terms. So write down your coefficients. So 1, negative 2, 5, and negative 10. 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is 0. 5 plus 0 is 5. 5 times 2 is 10. 0. All right, so we are left with x squared plus 5. So that's the equation that we are solving. So we can solve this one by the square root method. So minus 5. So remember, the square root method is just solving algebraically. So undoing the order of operations. All right, so then at this point, we've got x squared equals negative 5. We square root both sides to get rid of squaring the x. So we get x equals plus or minus. So remember, anytime you take the square root, you got to put plus or minus. So you've got your principal square root, which is the positive, and then you've got your secondary, which is obviously the negative. That's where your two solutions come from for a quadratic. Negative under the radical, so that means that our solution is imaginary. So we change that to a plus, and we pull out an I. And then we cannot simplify the square root of 5 because 5 is a prime number, so the only factors are 1 and 5. So it's just going to be plus or minus I, and then square root of 5. All right, so that would not be your final answer. Those are the two that we found. Final answer is all of them. So the first one that they gave us, which is positive 2. So remember, we started with a cubic, so we should have 3 solutions, and we do. So we've got plus or minus I root 5, so that's 2 solutions because we've got the positive and the negative, and then the real solution, which was 2. So this right here would be your final answer with all 3 solutions. So you would list all 3 solutions, or if it was multiple choice, you would pick the one that has all 3. For this one, I need you to write down the method that we used to solve the quadratic that was left. All right, and then last question, number 21. So find all zeros. So again, probably not going to get them all when we graph it, but let's graph it just to be sure. So x to the third minus 2x squared minus 5x plus 6. Oh, okay. So we see all 3. Let's see if they're all rational. And they are. Okay, perfect. So final answer for this one would just be x equals negative 2, 1, and 3. All right, so that is the test review. For the summary, I want you to summarize, basically summarize the review, like the different concepts that you still need to work on, that you need to focus on for studying. So for your summary, everybody's summary should be different. If you put something, like if everybody has the same summary, I'm not giving you credit for your test review. So everybody's summary needs to be different because all of y'all are different. So I should see where you went through and were like, yeah, these are the concepts that I need to focus on. Like, I'm good on these. I need to focus on whatever you need to focus on. So everybody's summary should be different. If it's not, you're not getting credit. And then also, if you don't have the extra things that I told you to do while watching the video, then you're not getting credit for your test review either, because that is going to show me that you did not bother to watch it and learn from it like you are supposed to, because your assignment today is to do your test review. If you have any questions about anything in the video, please don't hesitate to email me. And happy studying.